Salud. I'm going to do it in English because it's prepared in English. Okay. All right, so welcome and to today's workshop on VR, AR, and it's going to be on haptics. We're going to have like several parts. If you can come front as well to introduce ourselves from the beginning. Hi. So I'm going to start with who I am. I am Esen, and I studied photography and video for my bachelor's, and then I did a master on cognitive systems and interactive media. And right now I am doing a PhD on clinical psychology and virtual reality. At the same time I work as a documentary filmmaker, visual artist, and also research on the AI, VR, or immersive arts.
My name is Macía, and I have a background in neuropsychology, and then I started getting into the whole like game development, real-time 3D kind of field, specifically kind of focusing on the combination between psychology and virtual reality or mixed reality in general. I have worked for several years as a research assistant in different labs, also working as a XR developer, technical artist, hobby producer.
Jack of all trades.
Yes.
So yes, all right. So we're gonna go over some VR basics, and then we're gonna look into the headsets, some concepts, and game engines, and then we're gonna continue. So the legend is not even enough, but it's gonna be kind of like an overall passing through what is VR, what is it used for, what it's based on, and then looking into capabilities or the projects that you can develop using these technologies. So if we go specifically, what is a virtual reality game? So it's an immersive game where the player is put into a fully realized 3D environment where it's surrounded by many elements that they can interact with. So this is usually done with a VR headset, although it can vary. And in the case of, for example, if we take it outside of VR into an AR, where there's pass-through involved with the latest headsets, it can actually happen also with elements that are spread across the real-world objects. When you do spatial computing, for example, when you scan the surface that you have around, you can actually place virtual objects on top of real objects, and then you can also create interactions in between them. So there are some concepts that we have to kind of like establish in order to understand virtual reality. So it's basically the core thing is the digital representations. Many of the things have not real life correspondence, although it is inspired from it, but it is in a digital format. And then we have the visualizations that is interactive, so any object that you do, or most of the objects that you have around, should be interactive in a way that you, with your input devices, so it can be hand tracking, it can be controllers, it can be microphone, it can be trackers, should be interactive. And then we have the 3D immersion aspect, which makes the VR the most important, like it's VR's most important asset. And then I'm going to talk about the implicit interaction and why and how it works. So when we look into the interactive visualization, this is kind of like the most scientific way of like visualizing things. But when we understand of visualization, we have to think of anything that is 3D. Objects are not necessarily only two-sided. Like it's kind of hard to explain it apart from the example of a paper. But even paper has a 3D existence in the real world. But like the idea of depth, so you can actually visualize any object or data that has a volume into it. And then there is the implicit interaction. The thing I said about like digital representation, so in the image it's like the most basic way. So if there is a sphere on the 3D area, you can actually grab it, look around it, so it has a volume and it has a level of graspability, just like in real life you can do. But it is separate from the classical interaction. If you remember this like visualization, there's this drawing of a man, like a face that has like a finger coming out, which is basically the reduction of all the interactions you can have into a keyboard and a mouse, where it's It's not natural because we usually are beings that interact with their hands or with their bodies, moving closer to an object instead of zooming with a scroll mouse. So it's kind of like this moving back to natural interactions that we usually have in the real world. And then of course the 3D immersion. Unlike having a screen in front of you, it can be a phone screen or a mobile, like a laptop screen or any big screen that you can imagine. That is, if that is your input, the moment you look and turn your head around, the input will be gone. Whereas in 3D immersion, the world is constructed around you, just like it is in real life, in a way that you navigate it inside it. It adapts to you instead of you trying to adapt to the technology or the content that is out there. By the way, in any moment, if you have any questions, please stop me. So if we kind of have a look into the architecture of a VR system, this can vary, but this is sort of like the basis that comes out from the user and comes back to this user, and it's a circle that repeats depending on the frame rate, depending on the refresh rate that you have. But usually the user is the core, and they take some actions, and these actions are usually received or interpreted via some controllers. It can be gloves or haptic gloves, some sensors, microphones, any kind of input device that you have is kind of like the interpreter of the user's actions. That is then using also like the positioning is also an input, like your head and hands position and tracking is then sent to the computer, and this computer can be in standalone VR devices, can be the processor inside the headset. So there's the data collection, computation, physics simulation, sensorial simulation, and all like the rendering of the geometric models of the world. Is then generated the video or audio or the other outputs such as screens, headsets, projectors, or haptic vest, that basically if in the demo it's going to be you getting hit or hitting something, and then the haptic feedback that you're going to receive will be the output, which stimulates the sensors, and it creates this loop, a feedback loop that is continuous and allows you to immerse yourself into this world. So now I'm going to mention, get into a bit of the headsets that we have and has been. So we technically have mainly two device categories. The earlier versions are the feathered ones, so these are the ones that act like a display device on another device, so you have to connect it with a cable to a video console, like the PlayStation headset, or to a gaming computer in order to kind of like process the game and then just pass the visuals into the headset. It's good, and it was important on the days where standalones were kind of like were lacking the processing power, didn't have enough chips, and the refresh rate or the resolution was not good enough. This served the purpose, but of course it takes away the freedom that you have of moving around. You always have a cable connected to a computer, and that allows you to, depending on the length of the computer, but always have something pulling you, and it's like kind of like against the whole idea of VR in a way. And then lately, especially in the last 2-3 years, standalone headsets has developed radically and have been even changing day by day. And these are the ones that has kind of like one serves all, has all the components inside integrated in order to give you the experience. So it has a speaker, but of course you can always connect your headphones, or you can add more trackers into it. But in itself, to have any kind of basic experience, or even I would say an okay experience, there are really good standalone headsets depending on the price range that you can afford.
I once tried standalone. I think I went to a place where they have like video games on virtual reality, and it was the standalone one, but I had like a really heavy bag.
Yeah, it was a battery bag, right?
Yes, and I don't know if it has improved these past years, but the graphics were also not really good. Maybe it was because it was a standalone, or it's...
Yes, it was because of the standalone. So it improved and not at the same time, because yes, it improved. For example, these headsets, the Quest 2s or the Quest series, after the dual output kits, you actually have the battery integrated. You use the USB-C cable to charge it, and it goes, depending on the amounts of times you use or the graphics that it needs, it can go like 3-4 hours. Would you say good
Yeah,
2 hours?
around that, yeah.
Yeah.
In terms of like the standalone versus tethered, well, like before, it is true that it was mostly like connecting through a cable into like a computer or like the processing unit that was capable of like rendering the application. But nowadays you can actually just connect through Wi-Fi from the headset into the laptop or the computer, and that's what we're going to do today. You know, so it's not completely true that right now we're kind of limited by cables anymore. But yeah, we'll look into that later.
Okay.
Exactly. But at the same time, for example, to give an example, like we have these that have the battery integrated, but now Apple, the new Apple Vision headset that I don't know if you saw it, like the AR integrated with the memories you can see and record. So that one, for example, is an advanced one, entre comillas, like between quotation marks, but at the same time you have a battery pack. So it's kind of like a little bag that you have to carry in their pocket, which is not still out yet, but that's like the plan. So a lot of companies such as Pico or HTC, Meta also try to kind of like integrate the battery so that it's like the least amount of weight possible or least amount of things to carry around or be connected to, whereas Apple, because of the things that they want to achieve, it requires so much battery to run, so that like they have the external battery they have to carry around. So
yeah, there's also a topic that some people don't really like, the idea of having like a battery here, like in their face. If something goes wrong, you know, some kind of circuit or whatever, yeah, not a good place to have it.
Exactly. Well, yeah, back, pocket, depends where you want to lose, you know, like
yeah.
Lose a leg, lose
Those are your priorities, yeah.
Exactly. So yeah, the standalone examples can be this is the Pico's new edition, for example, the Enterprise, which has AR and like color pass-through, that has the AR thing. I didn't put the new Quest 3, which also has the pass-through capabilities, and it's really, I would say, I tried both, and the Quest one is a superior one regarding like the spatial computing and the graphics. But then again, like this is also another option. This is the Quest 2 that we have with us, and then we have the Oculus earlier versions, and then this is the HTC.
Yeah, the third one, you said it's passed through. You mean that it's for
AR
so
as well. It's both.
It's not a screen, pantalla opaca, no es.
It
Well,
is.
it is. There are two kinds of pass-through, okay? There is passive pass-through, which is, for example, I don't know if you've seen like the HoloLens, which it actually is like glasses. It's just that it kind of like renders stuff on top. That's passive pass-through. But these are all active pass-through because it is an opaque screen. It's just that it uses the cameras in order to like render what it sees on the screen. You know, so if the battery turns off, like you run out of battery, you get blind. You know, like you don't see anything. Whereas like with the HoloLens or all of the stuff, you actually keep seeing. It's just that it doesn't have power to render things on top. So yeah, that's what it means.
Exactly. So you see that like these dark dots are the cameras. They're looking outside, and then they are rendering a continuous like video render. So like Quest also has it, but the ones that it has, and the ones there as well, was black and white, and now it's color. So it gives you more kind of like seeing the real world, but actually you're seeing a video of the world.
Yeah.
And like when you try it, you see that kind of like there's almost kind of like a fisheye effect. Like it's not the exact point of view that we have. So like when for example, a friend of mine came, I had the Pico on, and when you try to hug, like you don't have the exact distance of what it is, you know, like you can't really kind of calculate it. It's minuscule, but you can tell. But as you can tell, it's there. And then the tethered one, like I said, so you have the cable, the good old cable, or you have the tracking sensors. Like the good part about these ones is that like you can easily achieve like full body tracking. The untethered ones, although now using inverse kinematics, which is basically calculating the distance from the controller to your body. So instead of tracking your whole arm, it looks at this distance and then it tries to calculate your arm from the distance. So it's like inversing the mathematical process. You can actually do some tracking, and there are ones that are trying to do it with the distance that you have with the ground. Not fully legs, but like also trying to do like lower body tracking. Because one of the problems with these ones has always been, and it was a funny subject when the first meta kind of presentation came out, was that it was like floating torsos and nobody had legs, and I really found it really ridiculous. And it was because of the technical limitations that as you don't have these trackers, you can't see exactly your legs. You can do like this because you have the controllers in your hands and everything. You can kind of like tilt with the trackings like 60 OF, but you don't have any data coming from your legs. And that's kind of like the strong point of the tethered ones. If you want to jump in at any point, please do.
No.
All right, so moving to the concepts. So the one that I just said. So there's degrees of freedom, which is one of like the key points of understanding how VR kind of makes you more immersed, or the amount of liberty of movement it gives you. So the earlier versions had 3 DOF, so degrees of freedom. So it was the rotational. So the viewer may turn the head around and choose where to look into the VR environment. So you can just like turn, but you can't really change the position of your head. You can like, if you turn to the left, you see the left side of the content, and if you turn to the right, vice versa. But you can't really have this kind of feeling of depth. So normally when I get closer to an object, it gets bigger. Because the distance is lower and like it gets bigger in my eyes, although empirically speaking the size of it doesn't change. It's because the distance between us change. And in the 60 OF, it was almost, when you try to get closer to an object, it would get far away from you, because
So close, it's so far.
Exactly, it's so philosophical. It's because like they rendered it that way that it doesn't understand the distance concept. So you have to always keep the same distance for this to be how it was rendered, let's say. Whereas it's not new anymore, and I think it's like a staple by now. It's the 60 RF, where you have the rotation and the position also included. So if you do like this, or if you get closer and now, it also kind of like the VR environment adapts to your movements.
And what does the 3 on the 3 degrees of freedom mean? Because it's not the 3 axis, no?
With this rotation,
Exactly.
basically, it means that like you can move like this, you can move like this, and you can move like this.
Ah, okay.
Yeah.
It's those 3.
Exactly.
And then the 6 is those 3, and then whoop,
Multiplied by, yeah.
and this one.
Ah, okay. I
Yeah.
thought it was only to the sides.
No, like I did the thing wrong, and I like, you can do this.
Well,
but
yeah, you can do it, but it's not a very often like common kind of interaction, no? Like.
Exactly. It's something like people who use Blender or any kind of like 3D modeling thing, they know like the axes and XYZ, but yes, like it's there, but the way we really perceive it in the real world, it's more when you have the 6 axes instead of, or 6 degrees of freedom instead of 3. And then refresh rate. It's one of the key things if you're a gamer, like if you have a 300 hertz screen, you're happier. And it's also kind of like the base, like it's, so the refresh rate and the frames per second, it's kind of like linked, but in order to understand like the difference, so the refresh rate is the number of times per second that the image refreshes on the screen. So 60 hertz display will update the screen 60 times per second. And overall, the refresh rate determines how smoothly the motion appears. So you see that it's almost kind of like the amount of details that you can have, because it's almost kind of like the times that you can have more data coming in. And because of the material way that the electricity or energy travels through hardware, the bigger the screen, the more pixels to update, more work to do. So if you have a smaller screen, it's easy, you can have a high refresh rate, but if you have a bigger screen, or if you have a bigger display in the VR headset, it becomes computationally more heavy for it to kind of like have a good refresh rate. Nowadays, I don't know if I mentioned later, but yes, I'll mention later the refresh rate that we have in the headsets. And then the frames per second. So the frames per second is number of frames per second our application is showing in the screen. So that's like two different things. You can do it, like, for example, the movies usually are in between like 24.95 or 26 to 30 frames per second. The action movies have it more in order to have more input coming in, but then like 24 frames is kind of like the gold standard for the cinema. We as humans, we can perceive up to 124 frames per second, but then if you put too much frames, it's just because we perceive it, it doesn't mean it's good. Like 24 also is like the moment that the humans really feel comfortable, in between that until 60 frames. And the number of frame rates should be equal or higher than the refresh rate. So if you have a refresh rate of, for example, 60 and you have frame rate that is 30, that's going to be kind of creating a conflict, and it's going to create almost like this laggy feeling, and it might be, the movements can be not so smooth, and it can actually be annoying. So yes, almost all VR headsets have a refresh rate of 90 Hz, and we should aim to obtain 90 FPS or more in our application, and that's kind of like the gold standard. Does everyone do it? Not really. Like, do you always do 90 FPS?
I do like 300. No, okay, actually, like, so in the case, for example, of the Quest, if you're doing a standalone, if like what you should aim for is 72 FPS, and if you're going to like upload anything to like the Meta store or whatever, if you don't reach 72 FPS stable, they are not going to accept it, you know. Then if you are running it from the laptop, if it's like tethered, then the usual is to try to do 90. However, the Quest is actually capable of doing 120 Hz. It says that you have to turn it on in the settings, and yeah, I know some people just really want that, but it's not necessary.
Yeah.
Yeah.
It's kind of like, just because the number is high, it doesn't mean that it's gonna perform well, and sometimes it can actually be really annoying in a way of like too much information coming at all times, and it can be distracting. So it's also about like experimenting it, but like 90 is also a good sweet spot.
And you said the humans perceive a good FPS between 24 and 60, you said?
Mm-hmm.
And do you mean that after 60 it's like we don't perceive the difference?
Oh no, we do. We perceive it until 124 frames per second. Like perceive we do. But then, for example, it's also related to the distance you have with the input. For example, a 90 frame per second video game playing on a TV will not be as overwhelming as a VR. So that's why it's one of the reasons why people have like VR simulator sickness, no, but like this kind of mental tiredness. It's because of the distance that you have with the display that is so close by that if you continuously have 90 frames per second, 120 frames per second changing, your body and your brain can take it, but it's a lot of cognitive load that is like after 2 hours you probably will have some like headache or some like eyes kind of like getting tired. So that's also the complications. The resolution. This is not updated, so we don't have like the new ones, but there are various resolutions, and like the higher is better in a way. I would say that in resolution the higher is better always, like cinema, like TVs. The developer kits, like the Oculus ones, start with 640 by 800, sorry. And like right now we are at this level of 1832 by 1920. But then we have the HTC Vive Pro 2 or Vive Focus, who arrives until like 2448 by 2448. It's squarish, if you can see, because we have two displays, like here I can say as well. You have the two displays, the pancake displays in this case. So it's basically per lens, and then like also like kind of like joint way, because one of the choices that you can do that I didn't mention here is that in real life as well, what you see from one eye is different from the other eye. So we have a computation inside our brain that joins these visuals, and you can actually replicate this in headsets as well. Either you treat it like a full-on screen, like a laptop screen, and it's the same visual coming from the two displays, or you can apply the distortion that we have, like the distance that we have between two eyes, and have like a separate thing, and then let the brain do the rest of the calculation. And yeah, right now, for example, people are aiming more, or things are arriving more towards 2448. like Oculus, and I think in the Quest 3 as well, the display is more 24/48, maybe numerically a bit different, but around that number.
And the 5K and 8K would be like a whole screen, and
I think I don't like. To be fair, I don't know the Pimax 8K. Do you know the Pimax 8K? I have this visual from the.
Like I've heard of it, but I've not really tested it or anything.
No, me
8K
neither.
is a lot.
Exactly. To be fair, like this number doesn't correspond to this. You know, like this is not 8K. Like it should be. I don't think like maybe 8K is the name of the.
I just heard this from the Haptics.
Okay. I'm gonna say okay.
Yeah.
But I don't think like I would imagine 8K being too much. I haven't tested it, therefore I can't talk too much.
I think it's because these resolutions are they per eye, or they are the whole thing?
I
They're the whole thing.
I think it's per eye.
Per eye. Yeah, okay.
Yeah, that's why.
That's why. Yeah. Okay.
Yeah,
That's why.
that
this
explains the format as well. Like it's not horizontal. but it's-
Yeah. That's why it's 8K, because it's
Mhm.
like 3,840 times 2.
Multiplied by 2. Okay. Yes. So it ends up.
Maybe, yeah, okay.
Yeah. We'll check this out. Actually, it's jokes on me. Okay. So now going from the I'm gonna give this kind of intro, and then we're gonna look into the software itself, like the idea of the creative process in VR. Just like any process that you would have in order to launch any creative application or any project. First, idea, better in paper. Some I don't know, depends who you are and how you want to do it, but I think paper allows you to kind of see things in a more whole way. Instead of typing, you can actually write down, draw, sketch, and everything. But then also pouring down all the idea gives you this kind of dopamine release of being yeah, I did the job, but the hard part is actually discarding the ideas that doesn't work. So, and selecting the ones that are good. So think of 10, keep the 2, and the rest have the strength and the courage to actually take the 8 out. And then prototyping. So before getting into any kind of artistic visual thing, which normally is the way that you start the idea because you like the visuals, but always have a functional version of your idea first, with the interactions, with how it's gonna go, the behavior, how it's gonna be the representation of the person. Starting simple and eventually going almost kind of like a proof of concept, no art yet. If that works, and then you can have the kind of earlier versions testing it. One of the main things that happens when you spend so much time working on a project is that you lose the perspective on what is good or what is bad. So it's always good to have feedback from random people, random or your friends or your family, so that they can give you some feedback that you actually have not seen or have not realized that you needed it, and use those feedback to kind of polish it. The whole memes of any artist, be it a video artist or a classical artist or painter even, the whole meme of V1, V2, V3, V4, we always have more versions because of functionality, but at the same time because of iterating on the idea. There's always room for improvement. And once this part is done, then for me at least, the fun part starts of choosing an art style, choosing on the aesthetics, creating the look, and integrating these aesthetics in the different parts of your application or your design, and having a consistent narrative around it.
Sure, I am probably.
And then the good old bug fixing, but you can put bug fixing in before and after any kind of the steps, because there's always going to be bugs. When you add assets, it can be more bugs because you're actually adding more visual details, more graphic cards, heavy things into it. So that makes sure that there's no bugs, because nobody likes bugs. And then afterwards, if it's done, publish. And this is the conduct experiments is because of my PhD technically, the research, but at the same time this can be conduct experiments with the users or with the art consumers or anyone. You can replace that with any kind of inputs that you would want to have. All right, now the game engines, the rivals.
Whoa.
So we have two big boys. Uh, we have the Unity engine and Unreal Engine. So, one is by Unity Technologies, the other one is by Epic Games. The fact that Unreal Engine is by Epic Games already tells a lot in a way that it's a game engine that is really focused mostly on the 3D and hyperrealism. It's really popular among 3D artists and experienced developers, yes and no, because at the same time Unreal Engine allows, like, compared to Unity, Unreal Engine doesn't have, unless you are experienced developer and know C++, doesn't have that much like openness, but there's also so many assets and it's so easy to adapt, apart from the fact that it's 24 gigabytes and it's heavy. It's really fun to play with, and what you get at the end result is much more, for me as well, visually pleasing than what you get in Unity. But if you really care about the interactions, if you want more liberty, if you want to be able to create your own assets, and if you want to have like more control overall of the product that you want to have, there's Unity, which both of them are cross-platform. Unity has 2D and 3D, although right now 2D is not disappearing, but 3D is gaining more popularity and it's becoming more the main thing, so inevitably they're pushing that part as well. They both have integrated some AI tools, AI in a way that, for example, Unreal Engine has meta-humans, that is kind of like realistic humans that you can create agents from. Unity Engine released Muse AI in the beta version, and now they're going to release the main one that allows you to incorporate AI prompts to generate assets or scenes. And then there's also the integration of reinforcement learning agents, so there's some AI movements going on in both of them, and Unity uses C# as a programming language. So now talking about both of them for the demos and the projects in this workshop, we're going to use Unity, and I'm going to go over once again kind of like a refresher for you, the hierarchy and the inspector and all the little windows you have when you first open the game engine. But then also, to give you an idea, this is the screen or the window that comes up when you first, when you open up Unreal Engine and start designing stuff. So, Unity Game Engine. This is the main interface, and it's divided into various parts. The main ones, there's even more that you can add using the window. There's the package manager, etc. that we're going to see. But this is the main interface that has the hierarchy, that has the project assets and the console, and the scene and the game window, and the asset store. And you have the inspector here. So, looking into the scene view is your interactive view into the world that you're creating. You use this to visualize and select the position of the characters, the cameras, the light, all type of game objects. You can select them, manipulate them, and modify them. You can do it here, seeing it, or you can also do it in the inspector numerically, just like moving the positions and everything. I'm going to try to address game objects like Geo from now on, kind of like shortly. And on the left you have the hierarchy. So the hierarchy, as the name suggests, is technically that window that displays every game object Geo on the scene. Models, cameras, prefabs, inside the prefabs or game objects, the scripts, everything. Well, scripts more on the side as well, but like you see everything that you have in your game here. So you can also sort and group, add and delete game objects. And one of the key things to understand the hierarchy is like parenting or parent-child hierarchy. So you can actually link or group some game objects to A, to keep it tidy, and B, to share the capabilities or the interactions or the behaviors that you want that multiple objects, game objects share. Prefabs, do you know what is prefabs? Yes, nice, okay. They are reusable assets, and you can use them almost like a template that's like, which can be created new game objects in the scene. So it's kind of like the base, you can modify them, but it allows you to kind of like speed up your design process or game development process. And then we have the inspector on the right side of the screen. And it's also to edit properties and settings for almost everything in Unity Editor, like components, assets, materials. So there's many functionality to almost every piece of game object, and there you kind of define the behavior that the game object will have. And then you basically drag and drop or attach using like the search bar up there as well. Any kind of components that you want to have, any kind of behaviors that you want to add. It can be physics, movement, audio, meshes, and many more. And then if you want to add some custom behavior or any kind of custom components, you do it using the scripts. And at the bottom, finally, you have the projects and the assets part. So this also, on the top on the hierarchy, you see what's in the screen and the scene, and then at the bottom you see what's in the project. So you can have multiple scenes inside a project, and you can go back and forth. Here you will see the packages that you have, any assets that you have that you may or may not have in your scene. So in order to, you always have to better have it in folders because things get so crazy so easy. You can use the search bar in order to search for the thing, so naming also quite important, especially for the script as well. And then in the same tab on the right you have the console, your biggest enemy. It's the it's where you see the errors, warnings, and other messages. So like it's the color coding, it corresponds to what happens or the amount of gravity of the problem you have. If you have the red exclamation signs, you cannot actually not deploy or build anything, so you have to really get over that. The yellow ones, you can sort of work through them, but always it's good to have to not have any errors at any point. But if you have like few yellow ones sprinkled, at least in my case, I'm just like, okay, I can do that. So like the debug class is the big friend in order to get rid of any of the bugs that you would have. And then on the main, next to the scene, you have the game view. So the game view is the rendered from the camera or the cameras that you place inside your scene, and it presents your final application. You can use a toolbar here to like play, pause, or like forward, or just like stop the editor mode and just like join to the game view and then like leave it. So it allows you to kind of work on it passively and then activate the game view to see the final version of how things will be looking. And any questions by now?
For the moment, no.
No? Okay, cool. All right, so I think this amount of theory already is kind of like overwhelming, so I'm gonna stop here. And now I'm gonna invite Fran here to talk about the first project.
Well, thank you, Esen. So, well, it was very good to hear first like the conceptual side of VR and the kind of more theoretical concepts that we need to take into account when developing things. But now let's look at more practical implementation. So we're going to be using something called the XR Interaction Toolkit. So this was developed by Unity in order to kind of find like a standardized way of easily developing VR applications with different kinds of interactions. So instead of having to like think from a programming point of view, like, oh, how am I gonna like, you know, like when I move the controller, kind of make it look like a hand and grab something, like how do I have to do that? So with this, you don't really need to be thinking about the technical implementation about all of that because it's already kind of done for you, and you can just think about the higher level way of how you are going to add interactions and what the player is actually doing. So in order to download the package, you can go into the GitHub page here, and we've given you a QR code, but I don't think we need to scan it right now. Okay, so actually, in order to get this package, you can either download it, or you can also, here in the Unity Package Manager, basically this is the place where you download like any kind of plugins, either like custom made by other people that you have bought or downloaded, or things that are actually made by Unity. Here you need to download the XR Interaction Toolkit, right? And once you have that, you can also download like these sample projects. And like once we're done with the slides, I'm actually gonna open Unity where we have this open, and we're just gonna like go through it and kind of play around with it. I will actually connect with the headset, and you can see in real time like all the stuff that I'm doing. Okay. Yeah, another thing that is also relevant, especially more recently, is that until recently, in order to kind of like program stuff for VR, you kind of needed to choose, like, let's say, like plugin provider. So like depending if you were using like something made by Google, like for example the Google Cardboard, like years ago, or you're using something made by Oculus, now Meta or Vive, like you will need to kind of choose like a different plugin, and it will sort of work differently. It will have like different terms for things, but more recently there is an open source framework called OpenXR that is completely cross-platform. So nowadays you don't really need to be thinking about...
Full TV?
I think it's someone.
Yeah, thank you. So you don't really need to be thinking about like, oh, am I using Google stuff? Am I using Oculus stuff? Vive? You know, you just choose OpenXR, and it's kind of gonna have like the same implementation for everything. So yeah, so here on the slides we have like some GIFs from the things that we'll actually see later. But this sample project is actually very good because from the very beginning it kind of lets you edit and play with and see in real time different settings for locomotion and for interaction. You know, like even before thinking about like what is the player actually going to do, like grabbing this, grabbing that, whatever, you have to really think about locomotion. Like it's gonna be the most important thing when it comes to VR. Because if you don't do it right, you're gonna make all your users like motion sick, you know? So, for example, like if you have a big room and you can have like room scale VR, that's kind of like the ideal situation where you have like a virtual room that is like 3 by 3 meters and you have like a table here with some stuff or like some enemies, whatever. If you also have a room in real life in which the user can actually like physically move, then that's good because the kind of feeling of what's going on in VR and the feeling that you're getting in the motor system is kind of one-to-one. But we don't always have that. Like sometimes it's like people need to be sitting down or they kind of need to be like moving a bit like this, you know, like they don't really have much space, which will be my case soon when I try this. So when you're in that situation, you really have to think about, okay, how am I going to let people move virtually but not in real life? And you have different options. Well, for example, one of them would be teleporting, which means that you'll kind of let users to like point at somewhere like 2 meters away, like on the floor, and then point to that, and then you will like immediately jump to that, you know? That's kind of like the safest approach, because then like basically the thing that you want to avoid is that you don't want to have a discrepancy between the visual system and the motor system of the user, you know? So if the player character, if their camera is moving slowly towards a place that they are not actually moving, it's gonna feel strange, you know? And there are ways in which you can mitigate that, which we will see in the project in a bit. But yeah, if you go for teleportation, just like fade to black or just like immediately I'm here, suddenly I'm there, you know, it's much safer. But in terms of like mechanics, it's not that usable, it's not that fun. It really depends on what you're making. For example, like for a video game, I don't know if you played Half-Life Alyx. Well, but like for an action game, like it just works so much differently because we're used to like having like a joystick and kind of like moving, you know, at like a set speed or like different speeds. Like the kind of game mechanics are built on that. So when you have the ability to just like teleport like it's like in 1 second you can go like 20 meters away, you know. So you kind of have to think about if your game mechanics they allow for teleportation, you know, and the pros and cons of both of these things. So I think it is time to open the unit project, and we can look at things from a...
Now that I was seeing that video, what is better, to set up where the user can teleport or that the user can teleport anywhere he points?
Well, that's a good, that is a good question, and I think let's kind of like talk through it while we just see it in real time. Mm-hmm. Yeah. So just bear with me a second because I need to connect with, I need to take the headset, I need to connect to the computer. So the thing that we were talking before about like standalone versus tethered and all of that, like, yeah, basically, specifically for the Quest, you know, like the Quest came out like in 2018, maybe, or 2019, like the first one, and it was kind of revolutionary because it was like, it kind of became like a standard of like what a good usable and light headset should be, because it's kind of like 2-in-1, because it has everything that you need inside of it, because it's basically like a mobile device, you know, so it runs APK files, the same thing that apps on an Android phone are. So you will just be able to like just put it on and just play. You don't need a computer, just go for it, you know, which makes it very easy to like just pick up and go. It brought a lot of new players because of that. But also you can connect through cable or through Wi-Fi into like a laptop and use the laptop, and it's more powerful capability in order to like actually render and process stuff. It's just that this sort of becomes like a display and an input. So yeah, what we're gonna use is actually, I'm gonna connect through the Quest Air link. So like the Quest link is using the cable, which is a USB 3 to USB-C. You take it from here and just like, you can do that. But yeah, recently, like Meta specifically has made a lot of improvements on the Wi-Fi version of this, so we really don't need to do that. Okay, so I'm already entering the link, and you won't see it yet, but basically I have like this menu, and I'm able to see what's on the screen of the computer. Like I basically have like a desktop here, and I can see what's on the computer. Most of the time, I don't really know why. Sometimes you don't really see the screen, and this is one of those times. So I kind of have to do this like, oh, I have to like do.
You want me to help you?
Control P, which is the shortcut for playing in Unity. Yes, I need help.
It's coming.
Yeah. Amazing. Okay. Good. So I'm here. You can see what I see?
Yes.
Okay, amazing. Yeah. So yeah, this is very handy that from Unity you can just click play, and because of the OpenXR plugin, you will just be able to like connect. You don't really need to like make a build. You don't have to like wait when you make a change. You know, you can just make the change, just Control P or press like play, and it will be running in the editor, and you can just like see the changes and play with it. And something I love even more is that while I'm doing this, you can actually go on the laptop, and within the Unity editor, you can just like grab anything and it will update in real time. So you can even like grab me and throw me like 200 meters that way, and I will probably get sick, but yeah, well, the option is there. Okay, so as I was saying, so we begin with kind of like with some options and some overview of the locomotion system. Okay, so first the teleportation. So in this case, it has kind of become standard as well that like with one of the controllers, in this case is the right one, I can use the right joystick in order to indicate a place in which I want to teleport. Okay, so the way that they have set it here is that I can literally teleport anywhere. By the way, sorry, Mark, can you repeat the question that you were asking?
Yeah. If it's better to teleport anyway or set up the places you want the user to teleport.
Right, okay, that's a good question, and here we kind of have both, okay, because it is true that we have let people to teleport anywhere they want, which I think is nice. It really depends on the application, but it also has these things called teleportation anchors, and it means that as long as this reticle is inside of it, you will go into a fixed position. Okay, so I am here. It even changes the rotation. It kind of forces that, like I will rotate like this way. So it's really up to you. It really depends. I mean, I like giving users freedom. Okay. You know, I like the kind of like playful feeling of like discovery of like, oh, what is there? And you have the ability to go, but like, you know, it really depends. It's a case by case. Okay, something else that I've been doing this whole time I didn't really explain. So apart from locomotion, the rotation, that's also something that is kind of important to think about, because it is true that it is easy for people to kind of like rotate like this in place unless they have a cable. If I had the cable here, it would be super annoying. Also, I have no idea which way I'm pointing right now, okay? So yeah. Is the screen here?
No, more towards the screen or the TV.
Okay, no, it's fine. It's fine. But, well, what I'm saying is it is really not that hard for users to just rotate like this, but it can be pretty tiring, okay? So it is also standard that in this case with the right joystick, just by moving that, I can kind of rotate like a fixed angle. In this case, it's probably like 15 degrees or something like that. And I think that you can also make it so that it's 45 degrees. Okay. They probably also let you do. Yeah. I know. Well, it's fine. I just wanted to like make it so that it is not like fixed angles every time I rotate, but it's like kind of a smooth. Which that is also an option that you can do, but again, it will probably lead to more motion sickness. Like how conservative you want to be with all of these choices when it comes to locomotion, it really depends on your target audience. You know, like if you're doing kind of like a beginner VR application for people that don't really know VR, I think it's kind of good to let them teleport and to let them to rotate with the snap, like fixed angles. But on the other hand, if you're making like a super hardcore VR game for people that have been using VR for 6 years, I think it is a fair assumption that they don't really have that much motion sickness anymore, and that they are gonna want to have like that more like realistic and like, you know, in-depth locomotion.
That being said, we can mention the fact that like gravity is also an option in VR. So like you can actually teleport, but you can also fly.
Mhm.
So you can actually like disable gravity, and I think in this project there's also it, right? Fly disabled. I see it. Yeah.
Oh yeah, this is the thing that I wanted to check. Yeah, so this will be like the continuous. No.
So you can actually like fly. So this kind of like the control board here also is like defining how you can actually interact as well. I think that button you have to really like go exactly. I had to go really by and press it.
Okay, yeah, there. Okay. Oh my God! Whoa!
So technically, yes, you can
Okay.
float around, which is a whole nother way of like. It depends on the way. Because just because we perceive the world with gravity, where we have to walk around, doesn't mean that you have to copy it, and that's a good part of VR where you can.
Well, that's a very good point. That's a very good point. Yeah. Like take advantage of the fact that you are not limited by the physical world. You know, like that's why I really don't like when people just try to take normal situations from the real world and just make it into VR without really like taking advantage of the limitless, you know, the limitlessness of 3D. But yeah, anyway, so and apart from teleportation, what I've been doing as well is this kind of like moving with the joystick, you know, and I move. Wait, I move in the direction that I'm. Yeah, okay. So you can also like move with the joystick, and I'm kind of going the direction in which I'm looking at, right? This is kind of what I was talking about. Like maybe it is more realistic, it gives you more control, but you have to be careful with it because it can lead to motion sickness. However, do you also see it like the vignettes,
scope,
no?
Yeah, exactly. This.
Yeah, that is really smart. That's really smart, and that's kind of based on more recent research.
That like the focal point, when you make it smaller, you get less motion sickness.
Yeah,
because it's the sides
yeah. So this actually really helps. You can turn it off if you want, but I'm not gonna turn it off. This is really good. This is really good.
It's also linked with the fact that, so like when we were talking about depth, when you're walking in a whole world, when you're looking to the direction you're going, you actually don't look at the sides. You look into the vantage points, like the ending point. And like what Fran mentioned many times, the motion sickness is the fact that there's so many things happening in the same
And that everything is
resolution.
on focus.
Exactly, and that kind of gives you this kind of nausea, this mareo. And that's what you want to really avoid, because that's the most unpleasant feeling, and that can really intervene with what you want to develop. Yeah, flying disabled better.
Yeah. Anyway, let's move on. I mean, do you have any questions about locomotion? Or?
No, for the moment.
Okay, cool. So yeah, this sample project is pretty cool because, you know, it kind of showed you like hands-on about like lots of different interactables and things. So yeah, now that we've moved on from locomotion, the second biggest thing in VR when it comes to interaction, grabbing. It's kind of like the most basic kind of interaction that you can do apart from like pushing things or like doing that. And yeah, with the XR interaction toolkit, kind of gives you like different options of how objects behave. In this case, yeah, different tracking types when the objects are grabbed. Instantaneous, pyramid. This means that like it's not kind of physics based in the sense that it's not like really like getting the speed in which I'm moving is just like one-to-one. Like my hand is here, the position of my hand is here. That's where the object is gonna be, you know. Also like, whee! Anyway, yeah, second, kinematic, right. So this kind of more in depth, but basically with the kinematic ones, it basically makes, so in order for the physics system to work with an object, you have to add a component to an object called rigid body, which just gives it like some physical properties like weight and things like that. And in this kinematic mode, you're basically turning all of that off, you know? Like it's just like making it so that like it doesn't really do anything when it's grabbed until you let go of it. And then this is velocity tracked. Okay, so this is actually kind of like tracking the inertia of the way that I'm moving, and you can see that it's kind of like following it, but it's not like one-to-one. Okay. So yeah, this just tells you that like you can use this kind of like grabbing interactables as if they were buttons. So like once you have it activated, like once you have it grabbed, you can use another button to like interact with it as if it was like, yeah, for example, like, yeah, this will be good for like a gun or some kind of like weapon in which you can grab it and then you can like activate it or shoot or something like that, you know. So socket interactables is just, these are just, it's kind of like an easy way to put things into things. It's just as it acts as a socket, like you don't really need to like place it perfectly, but you know, you have the object like kind of close to it and it's already indicating you when you let go of it, you will snap to that, you know. So that's good for different kinds of interactions. So yes, so well, the first headsets, right? They didn't really have controllers, okay? So you either played with like a normal kind of like gamepad, you know, with like normal joysticks and stuff, like an Xbox controller, or you could just have like this kind of like head rotation based interaction, okay? And some people still do that. For example, for me to like interact with that button, I could just look at it, right? Well, look at it is kind of, so it really depends if you actually have eye tracking on the headset or not. In the case of the Quest 2, it does not have eye tracking, right? So when it talks about gaze interaction, it's actually saying just like head rotation interaction because it doesn't know where I'm looking. But more recently, like every year, there are more and more headsets that actually have eye tracking integrated. So it actually is like, it depends on what I'm looking at. And that can be helpful for advanced kind of interactions. But I don't think we really need to focus on this that much. So 2D UI, oh, I kind of skipped that one. Let me just go there. What? Okay, no. Let's move on. I don't think 2D UI is that important. Because, so the thing is that like, it's easy to just kind of default to like normal like interaction, language, interaction behavior, like the usual things that we have in 2D, like on websites or like 2D video games. Like I think we really need to take advantage of the physical aspect of VR. So I think that's why we should prioritize the use of 3D UI. And in this case of this sample, like we have like a good selection of like, ooh, joystick, ooh, sliders, and ooh, wheels, you know, so faders, buttons. So like I think it's good to kind of be more innovative and more playful and more physical with the way in which to interact with the application.
Sorry, Fran, 1 second.
Oh yeah?
Something's happened to camera.
No problem.
Okay, good.
It's the Unity, the black one.
Okay.
Exactly.
Please.
All good?
Yes.
Yes.
Okay, cool. And yeah, well, this is just showing like some interactables with some like physics stuff added to it, like physics joints and things like that. Ooh.
Cool.
Okay. Okay, good. I mean, yeah, this is not so much about VR. This is more like Unity itself, because you know there is not really that much difference between this and like a normal non-VR game, in the sense that like this is not like necessarily VR, but still it's pretty fun. I have to say it's pretty fun doing this. Ooh. Okay. Yeah. Okay. Well, so that was kind of like the overview of like all of these kind of different interaction like paradigms that the XR Interaction Toolkit offers. So yeah, I mean, for fun, I just kind of made like a very simple scene. It would have made more sense to do it in in the gallery because I kind of like recreated the the Espronceda gallery, and I just added some things there to break because I thought it would be fun. So I'm gonna open it with sing another scene. And I think I'm gonna turn off the music because of copyright. I should have chosen my band again. I don't care about the copyright for that. Okay, so yeah. So this is very stupid, but basically I just added like a sledgehammer so we can break art. And yeah, this this is so stupid.
No, it's not.
It is fun though, but it's fun. Ooh, whoa, that was dangerous. Yeah, we have to be careful to not break the real world. But yeah, super simple. So basically, like this is just like a grab interactable, and it has like a collider at the end. And once it collides with any other object, it's not breaking in real time, okay? Because like breaking things in real time and kind of like segmenting and dividing the models and stuff, that's really crazy. Like for the CPU, that's really complicated because in real time you need to be like creating like different meshes and like removing the original one, putting new ones. So what I did was actually like in Blender, I basically took like, for example, the 3D model of like the sculpture, I put it in Blender, and from there I kind of made like a broken version, okay? And I exported both. And once you touch the original version, it will like immediately swap the original version with the broken one. And all of the broken pieces, they each have like their own colliders and their own rigid bodies. So basically they will just fly away immediately. Yeah, it's pretty fun. Okay.
Do you
want to try anything? You have any questions?
Okay. Yeah, I want to try.
Cool.
Yeah.
You want to break stuff or you want the other one?
Maybe the other one just to try the physics and how it works.
I will break stuff after.
Yeah. Okay, yes, come here. So yeah, be careful, don't do what I did basically.
Yeah.
Like I got really into it. Maybe it's a bit tight, no?
Maybe it's just for the glasses. Oh, okay, no.
Yeah? Okay, right controller
Yeah.
and left controller. Okay?
Okay, so
I will press play for you, okay? Yeah. If you have any questions, just let me know.
Okay, so it's a bit strange because I'm seeing the real room.
Okay, that's maybe because it. Try to move a bit. Is it?
Okay, no.
Yeah.
Yeah.
Yeah, it's just that it's kind of telling you that you are like.
I thought it
Outside
was.
of the garden.
No, I'm seeing the main. Okay, now. If I
Wait,
look,
I'm gonna move you a bit, okay? Don't
okay,
get scared.
yeah, that's better.
How is it here?
If I move. Okay, now it's.
Yeah.
But you can move one step backwards so that your arms, when you extend it,
Yeah. Wait.
Backwards.
Yeah, there you go.
Exactly.
If you hit something, we'll let you know. Don't worry.
and then we'll bill you the price.
And to move, which.
Yeah. Okay. So.
Button.
So with the left joystick, you can kind of do the real move,
Okay.
right? Okay. And here with this one, with the joystick.
Pressing or.
No, actually, like if you're pointing at
Okay.
If you point at the floor and you move the joystick, then it will kind of let you teleport.
Okay, so it's by moving that.
Yeah, and if you want to rotate, sorry, just for a
Yeah.
second. Yeah, to rotate is the right one, just kind of like moving it like.
Okay,
like that to the
those
side.
degrees.
Yeah, you
okay.
rotate. Yeah, exactly.
Okay. And
Okay, if you want to fly, yeah, it's kind of annoying. Like you actually you really need to put your hand there and then
okay. And
press
now pressing something.
press
The back.
The other
the
one?
trigger. Oh, the
No, it's
the inner one.
give me a second.
Yeah.
Yeah, it's kind of complicated. This one to be honest. You have to push it maybe.
Ah.
There you go. Okay.
So it's-
And now when you use the left joystick to move, you will move where you are going, and you will not kind of stick to the floor. So.
Aye.
Like, look up.
Ah, okay.
Yeah.
And that movement always has that vignette around.
Well, you can turn it off. Is he
What?
flying? Is he flying?
I don't think you're flying right now.
No, I can't move over the
Well,
water.
you can.
Maybe we.
No.
Oh, no, you're flying.
Yeah.
No, you're flying.
Oh, okay.
Ah, okay.
Yeah, we can turn off the vignette, but I think it's good for a negative motion sick.
If you want to
Yeah,
get
yeah,
more
don't worry.
interactions, by the way, behind the walls there are some doors and other.
Yeah, there is
things.
stuff.
Like-
There is
There's
fun
so
stuff.
many stuff like.
Yeah,
Oh,
I
okay.
kind of skimmed through it because it was a lot.
Yeah, that's too much stuff. But you have some guns if you want to shoot stuff.
And okay.
Look, yeah,
Ah.
nice. It's the cutest sound response.
I just realized because when you start it, it makes that sound. So they have the audio source like play on start.
Exactly.
So every time you start, it just plays that.
Okay. And to leave it, it's
Yeah, you just let go of the. So there is, let's say there are two main buttons, right? There's like the trigger, which is like with the index finger,
Yeah.
and then the grip. And the grip is with this, you know. So when it comes to grabbing, you usually use this one. Yeah.
this.
So
There's one here.
yeah. That's a button.
Ah,
yeah,
okay.
you usually press it with this
The
this
thumb.
finger.
Oh,
No, not the
okay.
thumb, not the thumb.
Oh,
Keep the
back.
thumb there. Yeah,
Oh,
with
no.
that finger.
Ah,
Yeah.
And to rotate, okay.
Yeah, you can break that again. It's actually cooler than my version. I didn't want to see this one.
Whoa.
So just hold it, yeah, and then you can do it.
Ah, okay.
Like in real life, you have to hold it.
Yeah. And if you let go of it, it will just like,
Ah, okay.
you're just throwing it.
And okay. Ah.
Oh, the particle effect is broke. I don't know. It rendered. Yeah. It just needed some time to render.
Cute.
And those lines, it's like the path I should take to follow the steps, or
Yeah.
yeah.
I think it just kind of shows that like if you start the walkthrough, it will take you from one to the other, like pew, 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 like different stations, but you don't really need to do it.
Okay. So I can escape or something, or
Well, if you're flying, probably you can just go anywhere you want. Nothing's stopping you. I don't know if he's
no?
flying.
I think
I think he's flying.
I can't go.
Okay, maybe they
that.
will
Yeah,
let you
there's
go.
like a wall.
Well, we can turn it off if you want. Yeah, you're flying anyway. Good.
No, he was flying before and then he landed.
Yeah, okay, then probably just put collider so you don't
Yeah.
escape.
That the turnstile was the.
Yeah, so
Ah, okay.
You'll
That
see it.
turn.
Then.
Teleport turn. Okay. Confirm mode.
You can, for example,
Oh,
move,
that
the,
is.
move speed. If you move it up, then it's gonna like. There's a level where it can get
Ah.
too
Oh.
overwhelming, you know.
Yeah. What?
That's good enough, closer to what it is.
What is strafe?
strafe.
Strafe is just like drag, almost like move, kind of like lean.
Does it work like
This
that?
was a strafe move, I don't know what it was.
Yeah.
Yeah, you have to actually push it. You have to like hold the button and push it in order to
Yeah.
interact with those, yeah.
And what's that? The strafe?
Actually, I don't know.
Okay. Oh, so it's for each hand. Okay. And what does the scaling do?
Not sure.
Try it out. There's so many options that
Yeah.
like.
With the
With
like the ring finger, the button is like kind of like in the ring finger. That's the one for grabbing things. So it will probably let you grab that from a distance. So like this one.
that one?
No, this one.
Okay, with
So point and press that. I was letting you. Give me a second.
yeah.
Look at it.
Yeah.
Yeah.
Oh.
Yeah.
Oh, okay.
Yeah. It's that button. It's kind of a weird one.
It's on the floor now. You're on top of it.
Oh.
Yeah.
Ah, okay. I'm starting to feel a bit.
Yeah.
Almost.
I will touch something. or-
No. It's good. It's good. Go for it. Ah, my hand. Oh, you have to hold it, or
Yeah.
until it gets stuck to the top. I don't know.
Well, it's tricky, yeah? Maybe you need both hands with another joystick to
Yeah.
press with one and then use the
Oh.
other joystick to like have it grabbed and then move it to the grab area.
Ah, okay. It turned red. I don't know. That's enough.
Oh, that's
This
where
is
it
the
was.
2D UI.
Yeah,
It is displaced.
What? Yeah. Who wants to do the UI? Okay.
Alright. Shall we...
Yeah, break,
Exactly.
and
it's-
then we do
Okay.
haptics.
Okay, perfect.
Yeah.
Okay, if you want.
Yeah.
Can I quickly break stuff before...
Yeah.
We can pause the... Or no?
I don't know how.
Because it's gonna be like 15 minutes. Like-
Yeah, we're gonna do a break, so maybe.
Yeah, good.
Yeah.
Or if not, we can just continue. Right?
I'm putting the music back on.
Nice.
Yeah.
Can I make the Guardian bigger in there so that like I'm afraid?
Just do it there.
Where?
Just do it there. You have more space there. Yeah. Let me know when you're ready, okay?
Dun, 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 give me a sec.
You're going on the link now.
Yeah.
Okay.
Loading bar.
So you're not doing break or you want to do break?
Oh, this is the
It is the break. It is the break. Yeah, she just wants to break some stuff.
Exactly.
Yeah.
Ah.
Yeah. She wants to break
You'll see it on screen now.
Yeah. She wants
Your
to break
ex.
your ex
Your previous ex?
and your other ex.
Your
Your
other
other ex, yeah.
That's what you meant under break.
Yeah, yeah.
I thought that you wanted to have a break.
Both.
No, both. We're breaking things in the break. But this is okay. Yeah. But this is the break.
Alright,
But in the break, we're gonna break things, and then we're gonna have breakfast, and then we're gonna break the car.
Okay, I'm in the loading bar. I'm in the air.
You're in the link, no? Okay, sure.
Yes.
So
Oh shit, no.
it didn't work.
I'm in the air, but...
But how will we see what Esen is doing?
Maybe you're connected to my computer.
I think, I don't know what's going on.
Yeah, maybe you're connected to my computer.
Should I press play there?
Shouldn't matter.
Okay.
Okay, put it on my hands, right?
Right, thank you. Okay, now loading. Nice.
Okay, yeah, I'm putting the music back on. Yeah. Yeah.
Water.
That will show them. Yeah. Yeah, Michelangelo, goodbye.
Loading solving.
Yeah. Your other ex, yeah, don't forget about that one, yeah.
That's so fucking funny. Okay, cool. I think I wrote it all already.
Yeah.
Good enough.
First version, we'll add more things.
Exactly.
We'll add more access.
Oh, there's
Yeah.
like more axes anyways.
Yeah, just in case that you lost it.
Nice.
Maybe you fly away and ends up nowhere.
Nice.
Um,
So you wanna have a drink?
yeah. Time for a break, and we'll come back with some haptics.
Exactly. We'll come back. And then back to the release. It sounds you're coming at the end.
She said like 6. It's not 6 yet. Maybe we can wait for her and then we do the.
Yeah.
the thing.
Did you take some photos? Yes. Some videos.
Cool. Is there any alcohol in the house? No. I go to the shop and get. Yeah. I wonder if that was live stream.
I was also thinking
Me
I was
asking
gonna
like,
say
is there
so.
fucking alcohol in the fucking house? I need a fucking drink after that bullshit. Hey Marco, la tienda, ¿quieres algo?
Dime.
Que voy a la tienda que si quieres que te pique algo.
No,
All right. All right, so welcome to the second part of the workshop. And after the VR part and the basic toolkits for interaction, now we're gonna move into haptics. I will give you, like the previous part, some like background on what haptics is, how it started, where it arrived, and how you can actually incorporate it. And afterwards, Fran will do a demo session of a project that showcases the haptic vest that we have here in order to have a better full body feedback on the interactions that you design in VR. So before, let's start the basic. What is haptics? So the haptics comes from the word haptikus in Greek, and which means to touch, to feel, and interact. And it's the technology that can create an experience of touch by applying forces, vibrations, and motions to the user. I think it's one of the key points that we usually kind of overlook. Although when we look into the little details from our mobiles to smartwatches, it's always there. Any kind of feedback that is conducted through our skin or through our bodies that is not dependent on our eyes or our hearing is also one of the key points of designing immersive experiences. And it has a lot of applications, from automotive to art, aviation, medicine, to teleoperators. There's teledildonics, which is the sex industry, which is also the big part. Space, video games, virtual reality. So the list is almost endless, and that kind of also shows how widespread and given importance it is. So if we were to kind of go back into the history of haptics, it's just like many things in history. Haptics also are dependent on the wars and overall things that tend to distract people. So in this case, it's the case of radioactive material. So during the First World War, when nuclear weapons and uranium was found, people soon realized, after Mercury dying sadly, that you have to actually be cautious of the materials, and you cannot actually be around the materials so close by. So there were some teleoperators, early versions of it, where people would connect using joysticks in order to handle uranium or all these materials and to control it. So it was these mechanical apparatus that gave birth. So when you were to actually grab it, you would have more force. So it's kind of like the similar thing that we have. Objects in real life has a certain volume and a certain density. So I can't just squeeze it out, this thing, because it resists to my hand. So that's kind of like the idea of haptics as well. And that was like the earlier application, where if you were to grab the uranium, it would kind of like give you this idea of grabbing it really. It wouldn't just like allow you to close the claws right away. And then another example is like the Second World War era, where there was the first tactile feedback system for the airplanes. So especially with the control of the airplanes, when the engine was about to halt, it would give you this resistance so that it wouldn't allow you to actually control it. So when it was, for example, after you go down a certain altitude, it will be harder to pull back. So it also gives you kind of like the idea of resistance that you would have with the air. So these was kind of the first applications that is dating back to the 40s. And from then on, it picked up quite fast, and it became kind of like a staple in many eras. And all these examples was either the military industry or governments, but then the rise of it came, like many things, thanks to the gaming industry. So for this haptics, Sega and Nintendo were the earliest adapters of the technology, especially in the case. Like the most well-known aspect of haptics was introduced in the 70s. This is the motocross game from 1976 from Sega. So it's an arcade game where you're basically riding a motorbike, and the idea is that if you were to get close by any kind of motorbikes, or if you were to go out of the areas of the road, so if you go out to the field, it would create you more resistance, as if you're like driving on grass and everything. And it seems quite straightforward to us right now, but given back in the time, it's such a big change. It is such a half realistic feeling that it became a big hit. and it just like picked off in many cases. And then this was the arcade version, and then there comes the Dreamcast and the home version of motocross. And the earlier versions, which adapted vibrations or any kind of feedback, were the first ones that like took it outside of the arcade into our homes and give you reactions and the cues that would allow you and to link the interactions that you would have in the visual input with the bodily input. And then there was the first example that expanded from video games to mobile. So in 1996, vibrating haptics was first introduced to a cell phone using the Motorola Star Trek. And then it just went from here until to the smartphones, tablets, and smartwatches. So I'm gonna play this video, which is an ad from back in '96, or I can't. If I go like this, no, either. Why can't I play you? No, I can't.
Hold control?
You can watch it.
Oh, okay.
No. It usually like auto plays sometimes as well. No. Well, I'll show it to you another time. It's a quick video anyways. It's basically kind of like a joyous way of some spies are climbing up on a building, and then someone has like the vibration that distracts them and falls. So it's kind of like a jokely way of introducing this new technology. And this model really depended on this kind of, not dependent, but like made their advertising point using this haptic technology. And then Apple Watch is entering the game, and using like, if you give this example of Apple to many industries or products, Apples are always the ones that actually kind of, moves the industry. The case of Apple, the iPhone is the case that like smartphones became the main thing, and then the smartwatches they did, and then like Samsung and the others and the Fitbits followed. And now like they predict the same thing for VR in a way that the Vision Pro probably not be the hit, but it will be the one that actually creates the small startups or new companies or encourage other companies to actually start building more products in that area. And in the case of Apple Watch, they were the first one to introduce haptics into the wrist. So they had these vibrators that would feel similar to a tap or user's wrist, so to signal certain notifications and alerts. When in cases of like you don't really realize or you don't maybe listen to the sound that is coming from your wrist, but you definitely feel the feedback of it. Nowadays, one of the biggest dependencies on this is the medical applications to do remote surgeries or simulations. So it's for the idea that people who are actually far away, or if you really have to do some fine-tuning, really detailed operations in some small tissues, it allows you to really control until the millimeters and to actually operate when you're not in the operation room, which is great in a way that you don't have to travel now to the other side of the world to have an operation. You can actually have the same service from the best doctor who lives in Shanghai or Singapore or Australia, without you necessarily having to travel there. So this has lowered the costs and gave access of like democratizing the medicine in many fields. And of course the thing that like kind of is important to most of us or to this day is the importance of haptics and virtual reality and telepresence. So this allows people to kind of get away from this idea of dependence on audio or visuals for the feedback, and gives you such an immersive, I can call it better experience, especially depending on the games that you're doing, like the shooter game example that we're gonna have, where you actually feel the impact on your body instead of having this kind of like direct visual and done. It really allows you, but it can also, there are applications of gloves, like the example that I gave you. So basically there are various versions, and these versions, well, this photo is quite antiquated, but there are some gloves with the same visuals right now that basically are using the reverse physics, so that it creates tension in your hands, so it doesn't allow you to like fully close it. So instead of the object being here physically and resisting your pull or push, it's the wires here that are like not allowing you to clench it, so it gives you the similar impression of when you actually reach to something and grab it, you actually have nothing in your hand, but at the same time you can't clasp it. So virtually you see the object and you have the hand in the same position. So it's kind of like this illusion that creates as if you're actually interacting with a virtual object. In the Haptic Fest, there's this cases of hugging someone or intimate touch. It's one of the also researches that is about like VR and telepresence. I'm just showing this, which is kind of like the VR fail. So this idea of when you just have the visuals and audios, it just really doesn't really correspond to the real experience. So, for example, if there was the case that if that person had a haptic vest that would just like resist on their body, like kind of like a pressure on the chest, or instead of having the controllers, if they had the gloves that would just really grasp, this would have been a more immersive experience and a healthier one, instead of him just like falling forward, because knowing that like normally if you have a tree in front of you and if you climb, it should be the support point, you know? So it's this kind of disconnect between what we know in the real world and how we're trying to replicate it in VR. And if we don't actually give the full multimodal feedback, we see some failures happening. And like I said before, like you can use these feedbacks to, the haptic feedback to create or evoke sensations. This is paper from last year that is done by the research group of Anatole Lecquier, which is in France, Rennes. And the idea was basically that you had this haptic vest that would create some pressure on your body that would, if you are in virtual reality climbing uphill, it would just basically make you a bit short-breathed, and it would give you the sensation that actually you're giving that effort of this. And a follow-up research that they did and published this year is the public speaking anxiety, where a lot of people have difficulty regulating their breathing. So in that paper as well, you're watching someone who is giving a public speech, and you can actually modify the level of anxiety they have. And depending on the anxiety they have, it gives you the same sensation of anxiety and trouble to breathe. So it's kind of creating empathy in between people who are going through anxiety or distressful situations, and you having the same bodily sensations with these kind of applications. So it's really kind of like it's being explored as we speak as well, but it's a really, really promising thing. And now I'm going to talk more about kind of like the material part, like the implementation. How does it work? What makes like haptic feedback kind of do it? So first one, we have the haptic feedback. So these are the controlled vibrations at set frequencies and intervals to provide the sensation representative of an in-game action. So it can be like bumps, knocks, or taps. So these kind of sensations. And these are done by either two of this. So we have the ERMs, the eccentric rotating mass rotation, or we have the piezoelectronic actuators. These are the same ones that people use for microphones as well, which is dependent on the vibration or like the conductivity of the material. And these are motor based. That is like the vibrations. For example, our phones has a smaller version of this, whereas these ones are more found in kind of like reactive installations and stuff like this. Like these are obviously less space accumulating, but they like this is kind of like a basic version. And you can find different representations of this as well. And apart from haptic feedback, we have force feedback. And these are the ones like in automobile driving, video game simulators, where, you know, like the earliest example is if you had it before, I used to love it, these driving wheels that you would have for like computer games or PlayStations, that when you try to turn, if you were going in a certain speed, it would like kind of cost you to turn it. So it's this kind of like forcing you or putting force against your force. So it's kind of like this difficulty that it creates. Instead of like this tapping feeling, it's more like pulling or pushing. And that's the thing that that I mentioned with the gloves. So this is basically this. You have these wires around your hand, and you have this motor at the top, And these wires are basically the things that allows you to clasp your hand or grab things, etc. Another thing is air vortex rings. These are donut-shaped air pockets made out of concentrated gusts of air. These are really funny stuff, and I do really want to show you the video of this because it's of my favorite animal, the mantis shrimp. Let me just, I'm gonna use this tab, and I'm gonna quickly change the settings for sharing the screen so that we can go back to duplicate screen, and maybe that way the video will play. Duplicate. Yes. Alright. Let's give it a try this time. Okay, this is gonna be kind of like an example of. No. I thought you guys were seeing this. Let me fix this hiccup real quick, because I think it reverted. Yes, it reverted to the settings. Duplicate these displays and keep changes. All right.
Touch is a novel non-contact haptic feedback system that does not require the user to wear or carry any device. Instead, it leverages focused air vortex rings to impart haptic feedback at a distance. The prototype Touch device makes use of a microprocessor-controlled speaker as a diaphragm for producing vortex rings. To visualize the structure and trajectory of a vortex ring, we fill it with fog.
But it's not necessary, it's just to see it.
In this example, vortex is used to impart feedback to a user's chest with a vortex ring traveling at over 22 miles per hour.
So it creates really like proper feedback
this
to it.
example shows Touch hitting a target the size of a compact disc at a distance of 2.5 meters.
So, like, the idea is that this would be better for the haptic vest or in kind of shooter game, but sadly these ones are vibrators, for example, like, but of course this requires an external machine that would send you the air vortex, and this is something that you can find in nature as well, especially in the mantis shrimps. So mantis shrimps are these shrimps that have, so we have like 3 cones RGB, of color ranges that like multiplies our vision, and they have 12 cones, so the amount of range of colors they can see is 4 times ours, and they live in the deep sea, and they have this beautiful color. But what makes them even more special is not this ad at all.
They are the most friendly use of shrimps.
Exactly. Santiago, that's the thing. Another one.
Despite being only 6 inches long, pound for pound, he packs the biggest punch in the natural world.
The biggest in the natural world. He's the strongest for the amount of size.
This is the peacock mantis shrimp. He's actually neither a shrimp nor a mantis, but stomatopod just doesn't have the same ring to it. This guy's biggest problem right now is real estate. There are more shrimps here than there are crannies for them to claim. In a hot market, you have to move fast. All that activity works up an appetite. Time to bring out the big guns.
They did a real good job at sound design.
He's armed with the most sophisticated vision of any predator on Earth, and the fastest strike. His eyes work independently and together to better target his prey. These eyes detect more colors than any creature on Earth and see polarized light. He closes in on his target. The mantis unloads the ace up his sleeve. Hammer claws.
It
His
breaks it.
spring-loaded clubs strike 50 times faster than we can blink. For a moment, the surrounding water reaches the temperature of the surface of the sun. You heard that right. This crab is toast.
Yum, yum, yum. Yes. So, like, going back to this, so the idea is that this is not the accurate representation, but they punch so fast and so strong that before the punch reaches the object, the water around them evaporates, and the shock wave, the vortex rings that we saw before, kills the object before it even punches. So we're talking about force that is so like big, and this is kind of like the inspiration that created this air vortex rings. And then the final alternative to feedbacks are the ultrasound. So these can be used to localize pressure on a finger without touching or any physical object. And it's basically these kind of...
Elige tu seguro de salud con Mafre, la telemedicina más avanzada. Estés donde estés.
Ya está aquí el Black Friday más colorido de Mediamar. Descubre las ofertas que te sacarán los colores.
You're showing something interesting here. What is this?
So this is called, this is a Stratus Explorer. The company is called Ultra Haptics. And what they're doing is they're using ultrasound to create haptic feedback in midair.
I'm feeling haptics in the air.
Without touching the sensor. So they're using...
My hand is vibrating.
So they're actually using a leap motion controller there, which is tracking your hand position.
Okay.
And they're using that to position the feedback so it's always on the palm of the hand. And they move that around to create the illusion of 3D shapes in space. So we have this demo.
So this is kind of like the technology where there are different wavelengths of many like ultrasounds or any kind of sound waves or visual waves. So the idea is with this one you can actually feel the vibration passing through your skin and your skin tissue, and it can give you the idea of vibration or like resistance. It's also one of the technologies that is being developed right now. And after all this, let's get physical, and we're gonna move to the demo and development part of haptics. Let's go.
Okay, cool. Well, Sam, thanks a lot for a conceptual overview of haptics. So, yeah, haptics are known for being quite expensive and quite complex if we're not just talking about like controller-based vibration, which has become like a standard at this point. But yeah, well, for this demo, we're using this device called the TactSuit X16, which is attractive Spartan style. It's actually like one of the most like budget options for haptic vests, which are commonly used in like simulators or like kind of like first-person shooters, kind of like you know, like on-site games and things like that. So I'm just gonna wear it and kind of like go through how to implement it, how to use it, and how to implement it within Unity. So yeah. Oh, it's so tight.
You know? Let's loosen this up. No. Wait. Give me a second.
Yeah, let's adjust it a bit.
I don't know who was the last one who used it, but it was a tiny person for sure. Okay, how about now? I think now it's better.
Okay. Yeah. So yeah, so Haptics is, I mean, it's a good choice for like budget devices because it has this one, the Tactsuit X16, which has 16 ERMs, so it's like rotating kind of like engines that create the sensation of the haptic sensation. It has 8 in the front and 8 in the back, and basically it comes with like a player software in which you can like kind of create your own patterns of different feelings. For example, like you get shot here, or like you're having like a massage or something like that, you know. You can kind of like basically you can like take these 16 ERMs and you can like create your own patterns or just test them, and just to make sure that it works, I really like turning all of them on and just kind of getting a massage. It's pretty nice. Yeah, it works. Good. Okay. So the way that you implement this in Unity is very, very easy because it comes with an SDK and you really don't have to do that much. Well, first of all, you install the SDK through their website, and then here you will get a context menu and a developer window in which you will just need to, from their website, you will need to get an app ID and an API key. And it's completely free. Once you've bought it, you know, it's completely free to get these API keys, but you need to get them and put them in all of your applications. So once you've done that, it really is not that much complicated for simply adding this prefab, which has a script that will simply launch the, well, just launch the player so it connects to the Unity session. And I've just made this game, very, very simple game, in which there are like these drone kind of turrets. Actually, I realized I'm also gonna need this, because this is VR and haptics. So yeah, I need to do this as well. Okay. Okay, so just gonna. Oh, it's so stupid. Sorry, I'm just trying to like do the Guardian stuff and it's fighting against me. Okay, let's just do stationary boundary and I'll probably get killed a lot, but yeah. Let's go for it. So connect through link. Okay, so I just made this simple game which there are these turrets that are shooting at you, and it has like increasing level of difficulty, and you can have like more turrets or whatever. And the turrets will always be aiming at your body, and if they manage to hit you, then you will feel in the location where the bullet hit you, you will feel like one of the ERMs activating, so you will feel that you're getting shot. Well, not literally, but you will feel something. And then, I mean, the goal with like VR mechanics and the controllers and stuff, the goal of the game is just to like stop the bullets with your hands. And yeah, I made all of the sound effects with my voice, so it is pretty cheesy. Like it sounds kind of funny. And I also put, in order to have some intense music in the background and not have copyright issues, I put the song from one of my bands. So if it's too loud, I'm gonna give this to Sang so she can control the volume.
Don't worry about it, I got it.
Okay.
Let's lower it just in case for a bit.
Yeah. Yeah, here.
Right on here.
Maybe the sound doesn't come from. Ah, wait.
I think it's
No.
mute.
Yeah, it's muted. I muted it. Oh no. Yeah, here we go. So, yeah, super simple. Like, you know, the thing is like shooting at me, I have to like get the bullets with my hands. I mean, now it's like in the super easy mode because there are no more turrets. I for now, I just kind of have it with
Should I
one.
activate the other turret?
Yeah, actually, yeah, do it.
Alright.
Yeah,
Okay.
they are just like the activated.
I know.
Yeah. I mean, they're gonna destroy me, but.
Okay, second one activated.
Okay, good. Yeah. And yeah, anyway, well, when I get shot, I feel it. Okay, that really is it. There's not much more to say. You just have to experience it.
Okay, I'm gonna activate the third one.
And you can also like increase the rate of fire, but fuck
Yeah.
it, no, let's not do that. And I couldn't set up the boundary, so like I can't really move around, and I don't want to hit things, so I'm just kind of like stuck here, like just moving my hands like crazy. Anyway, yeah, that's kind of it, man. Like super simple implementation. Oh, hello, hey. So yeah. Any questions?
For the moment.
Yeah. I mean, it's very
try.
simple. Like you plug it in, you put a script, and then you can like. So the way that it works is that you kind of like make like predefined kind of like, I don't know how they call them. Let's call them like events. So like kind of like feedback events. So like this one, you feel this one, then you feel that one. You know, like something kind of like doing like this, like an explosion or something like that. Like first you create that, and then you just trigger them through the scripts in Unity. So it doesn't really have like out of the box a thing that detects where, for example, there was a collision, like where you got shot or whatever, and it vibrates in that area. It doesn't really do that. You have to do it by yourself. So for example, what you will do is that in Unity, when you get a collision with a collider, that will be, for example, in this case, like one of these lasers, you just kind of have to do like a bit of geometrical math to be like, okay, it's coming from here, therefore activate this one, you know, or it's coming this way. You just kind of compare the trajectory of the object, with the location in which it collided with your like capsule collider or whatever you're using for your character. So you kind of have to do that by hand. Apart from that, it's super simple. And yeah, I don't know. That's really it.
Would you like to try?
Yeah.
Do it.
I don't even know what it is.
Really, you just have to like move your hands and like stop like the lasers, and that's it. And if they hit you here, you feel it.
Okay.
That's really it.
You tried it already?
No, not yet.
Ah, okay. A ver.
Yeah, it's better if you close it. Good.
Maybe we can push the laptop a bit towards here.
Yeah,
Just to make sure that like no harm is done. Okay, yeah. That's good enough with the cable. Yeah, so that you have to, exactly, thank you.
Yeah, better. How's it? It's a bit loose, no?
A little bit, yeah.
Yeah, okay. So basically, when this happens, like you see these two plastic things here.
Mm-hmm.
So the more far away they are from each other, the tighter it will be.
Okay.
So I think it's best if you kind of adjust it for yourself. It's hard for me to tell.
Okay.
Yeah, is that a bit better?
Mm-hmm.
Okay, good. So now I'm gonna give you the right controller, and now I'm gonna give you the left controller.
Mm-hmm. We can kind of see you guys. Is that normal?
Yeah, okay, that's because you're kind of like outside of the area that I set up, so the device is like, oh no, you're gonna hit something, no. So it wants you to like see the world, but I think if you kind of get a bit closer to here, then you don't really have that, no?
Yeah.
Okay, I'm gonna press play now. So, yeah, I mean, at the beginning it's gonna be pretty, there's just gonna be like a turret just shooting at you, so try to like block the thing with your hands. And if not, it will probably like hit you on the chest and you will feel some vibration.
Okay.
Pretty much. Okay, no. It worked?
No, I don't
No,
see
okay, wait. What do you see?
I see palm trees.
Ah, right, okay. Sorry. We have to connect into the laptop. Probably easier. Yeah, just give it to me for a second.
Okay. Oh, the battery died?
No, it's just that it disconnected from the link because like we're not actually running it from the headset itself. We're actually like, well, maybe the controller battery is a bit low. I don't know, but we're actually like kind of connecting wirelessly into the laptop, which is the thing that is actually running the application. So first we have to do that. Like sometimes it just disconnects. Okay, go for it now.
Okay.
So
Yeah, I
right
see it.
controller here, and left controller here. Okay, and now. Yeah, the sound effects were done with my voice. Okay, yeah, the beginning is gonna be easy. Then I will make it hard for you. But for now, enjoy the simplicity. Okay, I'm gonna activate another one. I'm gonna put the bike next to it so that you don't get hit from behind.
Ooh.
Now it should be like close to the other one.
Do you feel the vibration?
I do.
Yeah, there you go.
Okay. I just don't wanna. Hold on, I gotta go this way.
Fran, be careful.
I mean, and that's really it. Like, I'm just gonna make it impossible for you, man. So, hey, shooting rate. Ah, I have to decrease the shooting rate in order for it to go crazy. I think. Let's see. No, it's not doing it. Yeah, whatever. Let's add the third one.
Ooh, there's 3 now. Okay.
Yeah, now the red. Oh my god, that was very close. And now the red one is gonna start shooting very fast, I think.
Okay.
Yeah, so just, I mean, I'm sorry, you can't win, man. Like, yeah. Okay. And yeah.
It's like the Matrix.
Yeah, I don't know. It's
Nice.
just super simple implementation. Like we also have these gloves, but the thing is that we didn't really like receive them in time to develop this. So I kind of just did like the stuff that we could with the vest. And yeah, I don't know. That's it.
Cool. You guys made this today? The whole thing?
No. This was actually we made this for a previous talk. Yeah. And well, for today we also made. I think I closed it. We also made like a game where you're like in the gallery there, and there are like all of these sculptures, and you use a sledgehammer to break them. Yeah.
You wanna go?
Yeah, that's right. I think it's too
Oh yeah,
normal
it's
for
too
me.
tight. The bottom one and yeah.
I think you
Oh.
like put from here. I think I'm not really sure, to be honest.
Let's try.
Let me help you. Oh, you got it.
There's another one here.
Yeah.
Yeah.
both.
I don't know if I'm doing it.
Yeah, right.
Sorry, I put it really tight.
Yeah, okay. It's getting less tight now, huh?
Okay, it's
Yeah,
better.
okay, good. Yeah. Try now?
Yeah.
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 Maybe you're a bit more. Or, yeah.
Yeah.
Okay, cool. Yeah, you look good. Yeah. Okay. Now, this again.
Okay.
Although probably will be a bit tight after
I
some.
think it's well.
I'm gonna make it a bit less tight, okay?
Okay.
Try.
It's for the glasses.
Yeah, it's for the glasses always. Okay, like this and.
Okay.
Okay. now-
Good?
Yeah.
Okay. So, right controller.
Okay.
Yeah. You don't need to press any buttons or anything, it's just moving the hands,
Okay.
okay? And left controller.
Okay.
Okay? Ready?
Yeah.
You see like a
Yeah.
white room, no?
Let me check the room. Okay.
Yeah, wait. I'm just gonna move you to the left a bit. Yeah? You're in a white room, no?
Yes.
Okay, good. There you go. Okay. You're good, so I'm gonna make it harder. Okay. There you go. Get shot, come on, come on. Feel the haptic, get shot. There you go.
I think the cable is like... Okay.
Ah, don't worry, you're good. Yeah, we should decrease the volume of the getting the points. Ooh.
I never see the green one. It always gets me.
This probably goes against like all the safety regulations. Well, fuck it.
I think I'm not that good.
I think you're doing pretty good considering, man. Yeah, anyway, I'm sorry, man. I really don't know how to make it interesting after a couple minutes. This is like the only way to make it. Yeah, that's really it.
Oh, the glasses are...
Yeah.
That was fun.
Do you have your computers with you?
Sorry?
Do you have any computers?
I have my computer.
Yeah, like
me too.
after these talks, like we really are available to kind of like go through your projects with you guys and like offer some help.
Exactly.
Yeah.
And apart from it, like we can share with you the project of the toolkit. You missed it. but
Yeah,
we
that
will share-
was more important.
Exactly.
Yeah, this is just kind of for fun, to be honest. Yeah.
Yeah, but we
Yeah.
have the recording, so
Okay,
you can
Yeah.
help from there. So, yes, I guess this will be the end of the class session, and then we can now have like hands-on and stuff. So,
Yeah.
if you want to finish the
Yeah, I think we're done with the live stream.
Okay.
Yeah.
Maybe you can say something.
Come here.
computer.
So yeah, we
Give me your
laughed, we cried. You know, it was really fun times. And
Thank you for
sadly,
joining us.
everything has to come to an end,
Exactly.
and this is the end. So.
Thank you so much
Goodbye,
for joining.
and thank you for your attention.
Thank you.
Okay, I will stop the stream and then here.